Let me start with something visual, and this keynote is more, of course, on behalf of Nevomo as a partner of the conference than of the Hyperloop Association. So what you're gonna see here is the impact of the staged approach to Hyperloop that we've been proposing for a couple of years already. How this can be combined with existing legacy railway infrastructure in order to facilitate deployment and above all have a network effect as soon as possible, because we strongly believe that Hyperloop should be connected to existing railway network just to have a smooth, seamless transportation system. Okay, so you were able to see a bit how this transition can look like. And at Nevomo, we strongly believe this should be a transition since we have especially in Europe, we have a very dense railway network that is about, 200 years old, the whole system. Of course, the network is not so old. And we should start by improving this. And then, at the same time, of course, develop Hyperloop as greenfield infrastructure, but interconnected with the existing legacy networks. All of you, we had to came here. I think I arrived at 1 p.m. a.m. Yesterday night, just because the flight was delayed and everything is congested. If we speak about road, air, and other modes of transportation. There's been a lot of hope placed on rail, but rail really needs to be enabled to be able to deliver to the promise of being the most green mode of transportation. We see a couple of issues, and most of them are linked to the very physics of the interfaces that the railways use. So first of all, it's the traction interface. So if we keep using steel wheels running over steel rails for traction, we're running into trouble. It's a perfect interface for keeping the direction and as well for maintaining a cruising speed, because it's a very low friction interface. But if we use it for acceleration and braking, the low friction really works against us. The braking distance for high-speed rail for 300 kilometers per hour is 4 kilometers, it's really insane comparing to road transportation. That's why the capacity is much lower than on road. Then we have another limit of the catenary interface. Nobody is able to run faster than 350 kilometers per hour using catenary. The speed record is just not, the 574. It's not possible to maintain this type of speeds on operational level because of the costs. And it means that railways cannot compete with aviation on any basically route bigger, longer than a couple of 100 kilometers. And all this combined means that we have to build new infrastructure if we want to add capacity. And this costs really a lot of money and takes a lot of time. Normally in Europe, I'm looking at Harge coming from the UK, right? How long has it been for HS2? 3 decades, something like that, since inception? Exactly. So we really have to count it in decades. And then the guided transportation system is getting a lot of pressure now from 2 sources. Automotive and aviation, especially automotive, which is becoming greener now, and politicians. There's really a very ambitious political agenda, especially in Europe, with Green Deal, putting very high targets for railways to be achieved already by 2030. And we all agree here that Hyperloop can help to do that. But the impact, if we want to have a network, we cannot have a Hyperloop network by 2030. So if we want to have we hope, of course, we hope to have first implementations by then, but having a network will take more time because it's just building new infrastructure. So having to comply with the ambitious targets, we need to deliver some solutions now. And what we did in 2018, we came up with this Magn concept, which combines Hyperloop elements with conventional railway infrastructure, so that we can have advantages of both. And the main target is to double the capacity, half travel times, and deliver it at a maximum of half of the cost of closest alternatives. This is the path that we believe should be taken by the guided transportation industry. So moving from legacy lines through Magn Booster, the first operational wagon you can see outside this building on track number 1, Stefan, right? In pole position. So please don't hesitate, visit us. It works, it's operational already. We hope to start implementing it next year. And then what we showcased, and I'm going to show it to you again in a second, 2 weeks ago at an event in Brussels, is this fully levitating version, where we need to have, of course, new vehicles, speeds of up to 550 kilometers per hour on existing high-speed lines. And then it all in our approach should be interoperable and interconnected with new Hyperloop lines, so that we can have a network effect much faster, and that we can reach centrally located stations through modified railway lines with Hyperloop pods much more easily. Because this will be, unfortunately, a big challenge to get to the city centers. So here you can see how Magn Booster for freight looks like. We add the linear motor mover beneath the vehicle, and then the stator between the existing rails. And for the levitating version, we also have to add on the infrastructure side the levitation beams on edges of sleepers, and then we need to have new lighter bogies and the full vehicle. What as Nevomo we are offering is a step towards Hyperloop that can be implemented already starting next year. The first freight freight applications, and we also believe that this can very much enable Hyperloop, as this, especially in Europe, has to be done together with railways. Railways are very strong in Europe, and they have their own advantages, access to city centers and so on, and combining advantages of both approaches, in our opinion, is the best way to go. Also, to be able to make Hyperloop available faster. And just very briefly, the results of the tests that we performed earlier this year. I will show you the movie in a second. So this was a 2-ton bogie that we were able to levitate and accelerate to about 130 kilometers per hour on a 700-meter long test track. The most important thing here, in spite, of course, of the first time ever that we were able to see a levitating vehicle on existing railway line, is the braking distance. We were able to stop it from this 130 kilometers an hour at a distance similar to a car braking. So this is something that the railways have not been able to achieve, and this is the really main differentiator that can put capacity much higher. Or of course, we didn't manage to get to Mercedes accelerations yet, but this is coming hopefully a bit later. And the next steps, as said, next year we start industrialization of booster for freight, and then in the next about 3 years we expect to deliver the passenger version, and then of course a full-scale certification homologation center is needed for the levitating version, the high-speed one. Here we believe that it should be interoperable with Hyperloop. It would be best to have one facility of this type in Europe to tackle both systems at the same time, to minimize cost and maximize effect. And we have 2 potential locations under some initial discussions. So let me just show you briefly the levitation video, and then happy to answer any questions. So thank you very much for your attention, and again, we believe this is really the best way forward to achieve effects fast on existing network and to enable Hyperloop to be implemented faster and to achieve network effects in the most cost-efficient way. Thank you.